Last time we have discussed is the programmable timer. So the general tune that timers, we are applying the clock pulse, train of the clock pulse, and it works. In this case, digitally we are providing the clock. For example, in 885 microprocessor we have discussed earlier, 5 megahertz frequency is applied to run the 885 microprocessor. In place of them, okay. So we have to use 8253 or 54 timer to provide a train of the pulse. And so basically, what is actually advantage of this? So time, you have to adjust the time. For example, in case of 5 megahertz frequency, so what actually we are applying a train of pulses? It is uncontrolled train of pulse, uncontrolled clock. When the device is on, clock is on. Device is off, clock is off, like that. But in 853, okay, it depends upon the user. You can start or end the train of the pulse. So this is our advantage of this clock. This is the 5 megahertz clock, okay, provided to 85 microprocessor through the quartz crystal. The quartz crystal is an analog. It's an analog clock. It's an analog timer, we can say that, and this is the digital timer. Now, so there are two ways to provide this. That is, with the 8253 and 54, you can provide a train of pulse. That is a clock to 85 microprocessor. Now, what is the difference between the 8253 and 54? As far as the pin configuration, so both are pin compatible. Okay, it's having a 24 pins. 8253 also having a 24 pins. So, what is the basic fundamental difference between the 8253 and 8254? 8254 readback command is. Okay, we will see later what is the advantage of the readback command. What are the advantages and what will affect the performance of the device of the microprocessor which is connected to 8253. Then the next thing is that related to the operating frequency. Operating frequency of 8253 54 it is a 0 to 2.6 megahertz. 0 to 2.6 megahertz operating frequency of 8253. In other side, the operating frequency of 8254 is a 0 to 10 megahertz. Just see the frequency difference. 0 means you have to provide a clock from 0 to 2.6 megahertz. If you can use the 8253 timer, and if in place of that, if you can use a 8254 as a timer, digital timer, then its frequency ranges from 0 to 10 megahertz. Then the 8253 it uses NMOS, N-channel metal oxide technology, NMOS technology, and it based upon the 8254 based upon the hybrid metal oxide semiconductor technology. What are the features of both 8253 and 54? So first feature is that it consisting, the 8253 as well as 8254 consist 3 independent 16-bit counters. 3 independent 16-bit counters. Now, and all those are operates on the DC. All those are operates on the DC, and frequencies we have discussed. There is frequency for the 8254 it is a maximum frequency of 10 megahertz, and here maximum frequency is a 2.4 or 2.6 megahertz for 8253. Now another thing is that basically what kind of the language it can use. So for programming 8253 as well 54. So BCD language, binary code decimal language is used for the programming the 8253 or the 54. Now basically there are 6 modes of operations. 3 counters are there. 3 counters works independently. Each counter is a 16-bit, and so there are 6 modes of operations. There are 6 different modes of operations, and you can program these 3 counters independently through these 6 different modes. Okay. Now another feature of this is the various pins of in 8253 and 54. That is the thing is that so both are pin compatible. So there is no such difference in pins of 85 and 54. Okay. So only thing is that readback command is available in 85. Okay. Feedback command is available in 854. Then the piece of the A253 and 54. So basically, data buses are D0 to D7. 8 data lines are there. These are bidirectional. And there are 3 counters, and each counter has 3 lines. Out of them, the 2 input lines are there, and 1 is the output lines. And the input lines are clock, gate, and out. Clock, gate, and out. Okay. So you are going to apply the frequency to the clock. And what is gate? Gate is enable and disable. Gate is enable and disable. When gate is enable, there and then only programming is possible. Okay. So if gate is enable, means you are going to program the particular counter. So there are 3 counters are there. Therefore, each counter has 2 inputs and 1 output. Clock 0, gate 0, and out 0. So these are the inputs and outputs for the counter 0. For counter 1, clock 0, then clock 1, gate 1, and out 1. So these are the input and outputs for the counter 1, and for counter 2. So it is a clock 2, gate 2, and out 2. So these are the input and outputs for this. Okay. And the remaining pins are ground and power supply. Then chip select, read operation, RD bar, WR bar, write operation. When the voltage pin is low, then work as a write. And when the voltage on the RD bar is the voltage pin is low, then work as a read operation. It read data from the microprocessor, and WR bar is it write data into the microprocessor. And there are 2 sections of the block diagram. One section is called the interfacing section, another is the counter section. So the interfacing section, basically these blocks were used to interface the 8Z5 microprocessor. So data bus buffer, then read-write logic, and control logic. So data bus buffer, so it is interfaced to the microprocessor through the bidirectional 8-bit bidirectional data line D0 to D7. They are also connected to the counter by the bidirectional way. Read-write logic. So read-write logic having 5 signals: RD bar, WR bar, A0, A1, and CS bar. So RD bar means when the voltage on the pin is low, it read data from the microprocessor. WR bar means when the voltage pin is low, then it write data into the microprocessor. And CS bar, it is connected to the microprocessor. Okay, with the help of the 74LS138 decoder, that is 3S1 decoder used for the selection purposes. And A0 and A1 counter selection, that is, for example, if A0 and A1 equal to 0, 0, counter 0 is selected, 0, 1 is there, then counter 1 is selected, and 1, 0 is there, counter 2 is selected, and so 1, 1. Okay. 1, 1 is, so control word is there. Okay. What is control word? The data from the D0 to D7. Data available on the data bus is displayed, okay, in the control board. Okay, so we will discuss that. Now, the counter 0, counter 1, and counter 2. So each counter is 60 bit. Okay, it stores 60 bit information, and the 2 inputs are there: clock 0, gate 0, out 0 is the output. Like that, every counter having these 3 inputs and the output. So this is basically the block diagram of the 825 4 or the 5 or the programmable interval time. Now, the operations of this, just we will discuss what actually does each. That is when A1 equal to 0, A0 equal to 0, CS1 equal to 0, counter 0, like that. Okay. Now we are going to discuss one by one the operation of the counters as well as the programming of 825. Just see the programming of the counters. Each counter is individually programmed, and this program is done with the help of the controller word register. Just see, there is the contents of D0 to D7. D0 to D0. These are the contents of the. For example, just see the for the what is programming language for the 825354? BCD, binary code decimal is there. Okay, so you have to select BCD when is 1. When D0 bit is equal to 1, then it is a BCD. Then what is SC1 and SC0? It is used for selection of the counter. Means for example, D6 and D7 both are 0, counter 0 is selected. When the 0, 1, counter 1 is selected. When D6 is equal to D6 and D7, they are 1, 0, then counter 2 is selected, and both are 1, 1 read back counter. What is the read back counter? So just you have to explain how it is programmed with the help of this diagram. What is control word register? What is control register? Control word register means the data on the data bus, data available on the data bus is displayed. Okay, so this displayed is called as a control word register. Then M0, M1 and M2, that is D1, D2 and D3 represent the modes. There are 6 modes are there. 8253 and 54 works on the 6 modes. It is mode 0 to mode 5. Now RW0 and RW1 related to D4 and D5 bit of a control register, and basically it is the read-write control. What is read-write control? Means if it is a 0, RW0 equal to 0, then RW equal to 0, then counter latch command. What is counter latch command? Counter latch command means which counter is there. What is meaning of latch? Data is stored in the counter. When these are 0, 0, then we can say that the data is stored in the particular counter. For example, just see, if D6 bit equal to 0, D7 bit equal to 0, means counter 1 is selected. So counter 0 is selected. Counter, okay. Then if 8554 BCD bit is equal to 0. And after that M0, M1, these are the modes. So in the modes, for example, if it is a say that mode 0, 0, 0, 0, there is a mode 0. So we will see that this. Now there are 2 operations. So write operation and read operation. Write operation and what is the write operation? Write a control word register. Write a control word into the register. Write a control word into the register. Write a control word into the register. What is control word? Data available on the data bus. It is called as a control word. Okay. First you have to add the lower byte data. Lower byte data. Then load the higher order data. So this is the write. This sequence. First sequence is that write a control word into the control register. Data bus, available data on the data bus. Okay. Next one is load the lower byte on the data bus. Then add the load the higher word or higher data on the data bus for the control. Okay. So this then the counting starts. So this is the write operations, and it is represented in that. Okay, different operations are there. For example, just see the one example. If SC0 equal to 0, SC1 equal to 0, then what happens? Counter 1 is 0 selected, 0, 1, counter 1 is selected, 1, 0, counter 2 is selected, and it is a 1, 1. So this 1, 1 is there. It is illegal operation for the 8253. 1, 1 is legal operation for the 8253. Why 1, 1 is legal operation for 8253? 8253, there is no read-back command, so it is illegal operation. And when SC0 equal to 1, SC0 equal to 1, okay, so this means it is a read-back command and it is available for the only 8254. Keep in mind. Next time, M0, M1 and M. M0, M1 and M. If all bits are 0, 0, 0, means these are 0, 0, 0, these are 0, 0, 0, mode 0 is there. There are 6 modes are there. We'll see in particular what actually it does in the particular modes. But first we see selection of the modes. If D1 equal to 0, D2 equal to 0, D3 equal to 0, then mode 0 is selected. Mode 0 is selected. Next, then if 0, 0, 1. That is, I'm saying 1 is D1, D2, D3. Okay, that is D3 equal to 0, D2 equal to 0, and D1 equal to 1. Then mode 1 is selected. Then, if M1, M0 equal to 0, M1 equal to 1, and M2 equal to 1 or 0, then mode 2 is selected. Same fashion, if it is 1, 1, means M0 equal to 1, M1 equal to 1, M2 equal to X. X means any 1 or 0, then mode 3 is selected. Mode 3 is selected. Then, if M0 equal to 0, M1 equal to 0, and M2 equal to 1, then mode 4 is selected. Okay? And if the M0 equal to 1, M1 equal to 0, and M2 equal to 1, mode 5 is selected. So this is the programming operation of the 8 to 5, 4 or 5. You have to explain what actually, what happens. So this